We have 2 solar storms on their way to Earth, a lot of flare potential, and new regions keep emerging on the sun's far side. Those stories and more are in the news this week. If you want to learn how weather from our star causes impacts at the Earth that shape the future of our world, join Professors Dr. Jenny Meehan, Michael Cook, and myself as we guide you through a space weather certificate program like no other. To enroll in the Space Weather and Environment Science program offered at Millersville University, go to millersville.edu/SWEN. It's weather for the 21st century. This forecast also sponsored in part by CW Ops. Space weather this week is getting very exciting. As we take a look at our Earth-facing disk, we're going to be paying very close attention to this cluster of regions right here. But before we talk about them, let's talk a little bit about region 4191. This region is going to be rotating to the sun's far side here very shortly, but as it rotated to the hairy edge of the Earth strike zone, you can watch it give a little puff right here, poof right there. That, believe it or not, was part of a solar storm launch. In fact, as you watch up here, you can see a little bit, back it up just a little bit, you can see a little bit of glowing arcades right there. All of that was actually a solar storm that's gone mainly northwest of Earth, but it's on that hairy edge of the Earth strike zone, so we could get clipped by it. But that's not the only story. We also have been following a lot of active regions. We've got regions here as well as filaments, and they're all kind of interplaying together. In fact, as later on in that same day, after the 4191 launched a solar storm, look at this little filament right here that's kind of anchored in region 4199. You'll watch it partially let go, boof, right there. Nice eruption. Doesn't look like it's all that big a deal because the filament didn't really let go, but believe it or not, that's also an Earth-directed solar storm. In fact, it was a bit bigger than we thought it was. From the disk images, we wouldn't expect to see a total massive halo like this, but we sure got one. In fact, one of the M2M forecasters who had to fit it said it looked like an inverted triangle, or maybe a carrot if you're actually kind of squinting. Anyway, I said it was a very interesting observation because actually, when we take a look at the blast wave that came up from this, you can see the beginning of this blast wave in different base difference images here. You're going to watch this blast wave spread across the disk. But here we go. As it does that, you can actually even see it reach all the way up to this region up in here. But as you watch it continue to evolve, you see that it begins to have some darkening areas around the perimeter over here, all the way around. And isn't it interesting that as you look very closely, this almost looks like an inverted triangle, very similar to what we see coming out of the coronagraph. So what that tells us is that this whole region in here was likely evacuated by this solar storm. So it wasn't just a small blast in here, but a much larger part of the corona let go. So that's why we saw such a big coronagraph signature, and why we could end up seeing a much bigger solar storm at Earth than perhaps we expect. Now, as we continue looking, we also are watching this big filament here to see if it's going to let go. It has been actually involved with this whole cluster right here. Again, you're seeing lots of filaments being involved with these active regions. And if we take a closer look at the cluster of filaments, we're actually seeing an interesting phenomena that always seems to develop right around this time in the solar cycle. We start getting what I call these core filaments, really a lot of them being exposed. And it's showing here, you can see the core filament that was here with this is the one that actually erupted from region 4199. But you see this kind of an S shape here that goes like this, region 4202 and 4201. You also see core filaments in here and even in here. And the thing is, with these core filaments, if they actually launch as solar storms, it's incredibly dense structures that we see launch out, oftentimes coming with radiation storms as well. So we don't even need these big, massive flares and high-level radio blackouts to get some really strong solar storms launched. So we're going to be paying very close attention to these regions in the future, especially the ones that have these core filaments, because they could have very strong storm potential, especially when they're complex structures like this. And that also includes region 4205 and 4206, because you can actually see a core filament in there as well. So let's keep our eyes on these regions. And now switching to our sun's far side, we use stereo A imagery because stereo A has finally moved far enough in its orbit around the sun to stare at the sun from the side. You can see here's Earth, here's the sun, and here's stereo A. Look at that, staring pretty much from the west limb, which is really nice because as we set this in motion, here's region 4193, and you can see it launched a big far-sided eruption. This actually was a pretty big structure in coronagraphs, and it was kind of hard to tell whether it was going to be Earth-directed or not. But luckily, stereo A gives us the imagery we need to be able to tell that it's not an Earth-directed solar storm. What we also watch and want to pay attention to is region 4203. This was a region that was growing just as it, and kind of emerging on the sun's disk just as it rotated to the west limb. And it sure looks like it is continuing to grow. It might very soon will be a solar storm producer here. So we've got to watch this on the other side as well as we take a look at it from solar orbiter's view, because this could be a big player very soon. And now as we switch to our full sun map, we are very fortunate to still have solar orbiter on the sun's far side. In fact, as we take a look at that same graphic from last segment, you can see here's Earth, here's the sun, here's stereo A, but now you can also see solar orbiter in a great position to give us a full view of the sun's far side. So as we take a look at this map, in red you will see this is the front side of the sun that we can see from Earth, and then here in blue is the far side. This is what solar orbiter sees. And so as I set this map in motion, one of the first things I want you to see is that we've got some new regions in here, especially region 42, 07, 06, and 05. Watch these regions really begin to grow over the last few days, right before they began to rotate into Earth view. So this is a big deal because these regions now have just rotated into Earth view and they look to be extremely active. And now we know why. It's because they're brand new. So amateur radio operators and emergency responders expect to get radio blackouts from these regions. We also could see them as solar storm launchers. We're going to have to be paying very close attention because new regions are oftentimes the most volatile of all. We also have another region here that's going to be rotating into Earth view probably in about 2 or 3 days, and because it is a new region, it also could give us big radio blackouts. So we're going to have a lot more activity over the next probably week or two before things kind of calm down a little bit. We're going to get another coronal hole here in about, well, we'll start seeing it in about a week, but it won't reach the Earth strike zone for quite some time. But as I take a look at the other side, so this is the west limb now, once again in Earth's view, you can see region 4203. Let me back it up just a little bit because this region just started emerging as it left the west limb. You can see right here back on like the 25th and 26th, that's when this region really started emerging. So it has been growing and we've watched it from stereo A's perspective, and now it's beginning to rotate into solar orbiter's view. So we're going to be watching it on the sun's far side because this could definitely be a big solar storm player as well as a big flare player. And now returning to those Earth-directed solar storms, we switch to our solar storm prediction model, ENLIL. Now this is NOAA's version of the model. The top panel's density, the bottom panel's velocity. You're looking down at the sun from the North Pole with Earth being off to the right. And as I set this solar storm model in motion, you're going to see 2 solar storms being launched right here. The first one is that one that's going mainly northwest of Earth, but then you see that much bigger, faster one. That's the one that was launched by region 4199 and had that inverted triangle kind of halo signature. So you can see as they begin to get close to Earth, they kind of catch up and almost merge. Now that's not what really happens. You're just going to kind of compress them both. But because it's kind of a 1-2 punch here, their chance for the solar storms to be a bit more intense is pretty good. So NOAA believes that we should be getting an impact right about 2100 UTC on the first. So late on September 1st, possibly into the 2nd, but we should see some activity begin to ramp up just a little bit. I believe that first solar storm is probably going to give us kind of a mild impact, and then it'll really start ramping up. So if there's a mild impact at first, aurora photographers, you just hold on, because we probably are going to get a much bigger impact shortly thereafter. So expect storming to come down to mid-latitudes. We could see G2 plus possibly G3 levels on this one. Now, as we switch to our NASA's version of the model, they're only showing the one solar storm, the fast one, but they've got this one impacting about 1900 UTC, probably really close to the same time. So aurora photographers, we are getting some good consensus here that this is going to be a decent show all the way through the 2nd, possibly in the 3rd, into the 3rd before things calm down. So be sure to keep your batteries charged. And now stepping outside to take a look at our current conditions with our global geochron map. Over the last 24 hours, we haven't been dealing with all that much in the way of radio blackouts, save the one that we had on the 30th. We had an M2.7 class flare. You can see it right here. It actually gave us a little bit of a radio blackout at the R1 level for the ham radio bands. Wasn't all that bad, but it did last for an hour or two before things kind of calmed down. It didn't have a big radio burst, so it was a bit on the mild side. Outside of that, we've been sitting really just with a minor degradation, pretty much between 5 and 10, maybe 15 megahertz in terms of degradation, a little bit here and there, but not too much. It's just a lot of noisy active regions, but no big pops from really big radio blackouts. Now, as we switch to our ROTI scintillation risk for GPS and GNSS, these are frequencies that are a little bit higher than HF radio. You can see already we're getting big patches of enhancement for risk for scintillation, and this is because of that. We're still in that radiation storm that we've been ongoing for quite a few days now. The radiation storm has calmed down just a little bit, but man, the scintillation risks continues to be high. In fact, not just on the night side, that's a big deal, but even on the day side, you can see a bit of scintillation risk increasing, especially anywhere near those big storm systems. So if you're a maritime traveler and you're using sat-nav, expect to get a little bit of issues even in the on the day side of Earth. But that's likely going to calm down once this big solar storm passes, but you're going to have to hunker down until that time. Now, as far as aurora is considered, well, we're really not dealing with much aurora right now. So aurora photographers have kind of had to sit there and just wait for a little bit, but this is definitely going to change here over the next 24 hours. Now, switching to our moon, we are now passing through the first quarter phase on our way to a full moon, with a full moon being on the 7th. But by the 6th, the moon will be about 98% illuminated. So you night sky watchers, if you want to catch those dim objects in the sky and maybe some aurora with this solar storm, well, this bright moon is going to be a contender out there. So you're going to need to check your local rise and set times. And now switching to our solar storm conditions and aurora possibilities over the coming week, we are anticipating the 1-2 punch from those two solar storms that are headed toward Earth. At high latitudes, NOAA is expecting severe storm conditions. This is starting right around the 2nd, but we're going to be ramping up right around the 1st because we do have that first solar storm that's going to be a little bit more mild. So expect to be able to chase, if you're an aurora photographer at high latitudes, possibly through the 3rd before things calm down. But then it's only going to calm down for about a day or so, because after that we're going to be looking for that fast solar wind that is from that coronal hole that is just rotating into Earth view now. So aurora photographers, it looks like it could be a very good week for you. Now at mid-latitudes, well, we're still expecting major storm conditions, not quite as strong a storm, and it's not going to last quite as long, but we still have a very good chance for aurora as long as that magnetic field orientation is pointing the right way. So if you're a mid-latitude aurora photographer, it might be worth a look. And then yes, starting around Friday, we are going to be watching for that fast solar wind that could start picking up right about then. And now switching to our solar flare and dayside radio blackout outlook over the coming week, we are still sitting around 200s, a little into the 210s right now for solar flux, and that's likely going to continue. We're sitting at severe noise on the dayside radio bands. In fact, if you're an amateur radio operator, I'm sure you've heard it. It is pretty noisy out there. The X-ray flux is well above the seafloor. NOAA's giving us about a 65% chance of M-class flares at an R1 to R2 level radio blackout, and 20% chance of X-class flares at the R3 level radio blackout. That is easily going to last for the next 3 days. I'm pushing it out to even further than that because we've got quite a few regions on the Earth-facing disk who look like they could be big flare players if they just make up their mind to do it. And now switching to our radiation storm and polar aviation outlook over the coming week, we are sitting at the D2 minor range right now. This is at flight level 360, and we're likely going to be lasting there at least for the next few days. This is also the S0 range for everyone else at the moment, but we are sitting at elevated fluxes right now, and likely we're going to pop up very close, if not touch the hairy edge of an S1 radiation storm. And this is because we've got that big set of solar storms headed toward Earth, and as they pass over Earth, that's likely when the radiation storm is going to peak. I'm giving us about a 20 to 30% chance that we'll get up to an S1 level, but it's going to dip down shortly thereafter. So hang in there if you are dealing with this, if you're a high-risk passenger or a frequent flyer or your air crew. Be sure to pay attention to those ICAO advisories because things could change quite quickly. And if you're a GPS user, well, careful with the high latitudes because that polar cap absorption event is still ongoing. So the space weather this week is getting very exciting. We have that 1-2 punch of solar storms on their way to Earth. Aurora photographers, we could get shows clear down deep into mid-latitudes with this one, so be sure to keep your batteries charged. Now we expect to see something starting around midday on the 1st. You could start seeing a little bit of a ramping up of activity, but by the 2nd, things should be pretty good. And then, of course, if the magnetic field orientation of the storm is the proper way, things could last possibly into the 3rd before it calms down. Now, amateur radio operators and emergency responders, well, you know, we've got a lot of noise on the dayside radio bands. We have the radiation storms at the poles that's giving us some noise, and now we're going to have a solar storm on the night side of Earth. So pretty much all around the globe, things are tough. You just kind of hunker down and last through the next few days, and things should get a little bit better. And now you GPS users, well, you know, risk for scintillation is really high right now, especially on the night side and on the day side anywhere near storm fronts. And of course, anywhere near Aurora, once that solar storm hits, that's going to be a problem too. Dusk and dawn are never good. So, you know, right now, GPS might be a little bit glitchy for you right now, no matter where you are. So be sure to stay vigilant. And if during that solar storm, be sure to calibrate your magnetometers often. I'm Tamitha Skov, the Space Weather Woman. Thank you for watching.